We have done three types of biasing: common collector, common emitter, common base. Characteristics of transistor. Characteristics of transistor. Characteristics of transistor. I'm drawing circuit diagram to study characteristics of transistor. Then I will do transistor as an amplifier, then transistor as an oscillator. Then will be logic gate, then three types of junction diode. See, whenever not given anything, it should be always N, PN transistor in common emitter mode. NPN transistor in common emitter mode. Symbolic notation of transistor we are doing. N, P, N transistor. This is base. Emitter is earth. Now we connect forward biased voltage to base emitter through rheostat so that we can vary the current flowing through the base circuit. This is base voltage VB. Here we get VBE, that is voltage between base and emitter. Plus side is positive, this is negative. Current will flow from here. So current enters in this direction. Micrometer records base current. Entering side is positive, this is negative. This will give me IB. First rheostat, positive, negative, then collector is reverse biased again with the help of rheostat. N side positive, negative, this is called VCC. Second rheostat, voltmeter connected in parallel, records collector and emitter का बीच का voltage. This is milliammeter, which records IC flowing through collector. Please draw this circuit diagram. See, anything is nothing but Ohm's law only whenever current and voltage relation is given. Just run the diagram. थोड़ा फास्ट बनाओ.
Done, sir.
So for transistor, there are two characteristics. One is called input characteristics, other is called output characteristics. Now, what is input characteristics? The graphical representation of base current against base emitter voltage at constant collector current. So VCC or collector emitter is kept constant. This is in microampere, this one is in volt. Now base emitter is forward biased till 0.3, nothing will flow if it is made up of germanium. Then current starts flowing, which is like IV characteristics of PN junction diode. I have assumed here collector emitter voltage is kept 0. As I increase this collector emitter voltage, graph will get shifted downward. That means number of electrons entering in the base will reduce. So for same voltage, base current reduces. That means if I go on increasing collector current, collector emitter voltage, so electron entering in base will be slowly becoming negligible. All will get diverted in the collector. So धीरे धीरे ग्राफ ये नीचे आ जाता. This is called input characteristics, which is graphical representation of base current against base emitter voltage at constant collector current. Have you followed this? Why it is falling down? एक स्टेज आएगा पूरा ऐसा हो जाएगा. पूरा ऐसा होने का मतलब क्या? करंट इन बेस विल बिकम 0, सब करंट कलेक्टर में एंटर होगा. क्लियर? हेलो हेलो.
Yes, sir.
इस ग्राफ फॉलिंग डाउनवर्ड का मीनिंग समझ गया ना आपको? As you increase this collector emitter voltage, more charges will enter here and few will enter here. A stage may come where no charge is entering in base region, and we get all current flowing through collector and emitter only. So draw this graph. Yes, completed. Diagram.
Yes, sir.
Now output characteristics. Output characteristics. The graphical representation of the graphical representation of who is output in case of common emitter transistor.
Emitter collector.
Yes. So graphical representation of collector current against collector emitter voltage at constant base current. Now, as you increase this voltage, the collector current starts increasing and finally gets saturated. Suppose I keep at that time base current 5 microamp. If base current is increased, that means you have increased base emitter voltage. So actually pulling force increases. More electrons are pulled at same voltage. So we get this graph slightly shifted upwards. This is suppose base current 10 microamp. Okay, draw this much. This region is also called as active region. And further it is called saturation region. After this I am doing very important topic that is called amplifier. After amplifier, we'll be doing oscillator, then logic gate, then three special types of PN junction diode, Zener diode, solar cell, light emitting diode. That will complete this chapter.
Done, sir.
Now, transistor as an amplifier. Transistor as an amplifier. The signal which has to be amplified is superimposed along with base voltage VBB. Symbolic notation. This is collector, emitter. Emitter is earthed. Emitter, collector, base, the signal which is alternating is superimposed along with base voltage VBB because second is earth. Now when these two superimpose, then we get varying voltage between base and emitter denoted as delta VB and varying current delta IB. So can I say beta is ratio of change in collector current to the base current. So change in collector current, which is output current, is beta times IB because beta is greater than 1. So collector current will be greater than base voltage. So current gain is obtained. Current gain is obtained in amplifier. Now because of base current, we get varying collector current flowing through load resistance RL connected in collector branch. This voltage is VCC between collector and emitter. We get varying collector voltage. This is called output voltage. So draw this circuit diagram. First part I told we get current gain because beta is greater than 1. So IC will be greater than IB. So first part is that. Just draw the diagram first for amplifier. In amplifier we are not having transformer. In rectifier we had transformer. Yes, done till this diagram and this part.
Yes, sir.
Now we have to check whether there is amplification in output voltage or not. Now, this is my output circuit which is left out, collector and emitter. Now imagine if I turn this by 180 degree, in fact 90 degree. That means I make this arrangement like this. So this is IC. This is VCC. So can I say this is giving voltage to load resistance plus between collector and emitter? Can I say by this? Hello?
Yes, sir.
मतलब ये पूरा वाला वोल्टेज इसको मिलेगा ना, इधर एंड इधर. अब इसको रफ कर दो, चलेगा? सो VCC इज नथिंग बट ICRL प्लस VCE लिखने वाला हूं. चलेगा आपको? बैटरी वोल्टेज इज अक्रॉस this circuit and across this na total voltage. Hello?
Yes, sir.
Okay. So I can say from the figure VCC is ICRL plus VCE. So change in VCC should be change in ICRL plus change in VCE. But VCC is fixed, वो बैटरी है. So change in VCC should be 0. So I can say 0 is net change in ICRL and VCE. This means change in VCE is minus of ICRL. VC means output voltage is minus ICRL. Now what is meaning of this negative sign? Very important. Suppose VCC is 20, ICRL 10, VCE 10, so net 20. This is not changing. It will always remain 20, 20, 20, 20 throughout. So if this becomes 11, then this should become 9 or not? Hello?
Yes, sir.
When this is 12, this will become 8. Or if this is 8, this should become 12. So I can see that when IC RL is increasing, then this is decreasing and vice versa. मतलब opposite है ना, इसलिए negative लिखा. Okay? Hello?
Yes, sir.
अब इसका graphical meaning देखते हैं. This is VBB. Suppose it is 5 volt and signal is +1 to -1. So 5, 6, 5, 4, 5, 6, 5, 4. Signal will move like this. With this, we are ensuring that signal is never becoming negative in base. नहीं तो खुद का आवाज खुद को सुनाई देगा. Sometimes in mobile when you call, तो अपना ही आवाज सुनाई पड़ता है. That means base emitter is not forward biased that time. So signal is added with base in such a way that if this is base, this is signal, the result will be such that always resultant is positive only. मतलब ये अगर 5 plus constant 5 and this is plus or minus 1, then 5 plus 0 is 5, 5 plus 1 6, this way it will alter. Okay, clear this much? Hello?
Yes, sir.
Yes, sir.
So when this base voltage is increasing from 5 to 6, base current will increase, IC will increase, ICRL will increase, so output should decrease. तो ये ऐसा उल्टा हो जाएगा output. When this is decreasing, ये ऐसा हो जाएगा. So what you find? There is phase shift of 180 degree between input and output. Okay? Hello? Hello?
Yes, sir.
So delta output is becoming minus of ICRL. ICRL depends upon input. So when input increases, ICRL increases, but VCE becomes minus of that. So we say there is phase shift of 180 degree in case of common emitter amplifier. So I'm writing one word here. Negative sign indicates that there is phase shift of 180 degree between output and input in common emitter amplifier. Now voltage gain or voltage amplification is denoted as AV, is nothing but change in output voltage upon input voltage. Output voltage is minus ICRL. We will consider its magnitude only. Input voltage is input current, which is IB, and input resistance by Ohm's law, IR. What is IC upon IB? Is it beta? Hello?
Yes, sir.
So voltage gain is nothing but beta times RL upon RI. So if they say find voltage gain, two formulas, voltage output upon input, or you can say beta RL upon RI. Please copy till this from the year. So if paper is difficult, they ask numerical based on voltage gain, which is beta RL upon RI. And then after class, please wait for 5 minutes.
Okay, sir.
Yeah, done.
Yes, sir.
Okay, everybody is done. Aniket, what is meaning of reciprocal of resistance?
Conductance.
Correct, conductance. And what is beta here? Which gain? Common collector क्या common emitter? कल लिखा था beta is which gain? कॉमन एमिटर है ना वो, IC अपॉन IB है ना,
Yes, sir.
मतलब एमिटर वाला गेन है ना वो, तो बेस से किधर ट्रांसफर हो गया, एमिटर पे. सो बीटा अपॉन RI is called as transconductance. You all have completed full? Beta upon Ri is denoted by G suffix M, is called as transconductance. Transconductance. Therefore, I can say voltage gain is transconductance into load resistance. This is another formula for voltage gain. Conductance into RL, and AV is always greater than 1. Always greater than. Hello? Auntie? No problem. Office is open. I will give. The name of that person is Santosh Jadhav. He will be there. I will pass his number to you. Or when you come over there, you just call me. I will convey you. When you come in that building, Konark Darshan, first floor, office number 101, and it is just opposite, means just in front of me there is one Xerox bar. From outside also you can see the board, it is written Devendra Verma's Physics Private Tutor. No, walkable distance, hardly 5 minutes. There is a giant temple over there and next to that. And come towards Bhandup end, don't go towards Thane end. Yeah. So that means you have to, if you are coming by train, you should catch the sit in backside one. That means towards Bhandup end, not towards, that means towards CST end, not towards Kalyan. And if there is any confusion, you call me, I will guide you. Yeah. Oh. He will give you. Yes, I will ask him just now. I will look at it for you. Yeah. Okay. See, voltage gain is always greater than 1. Now, if still difficult paper comes, then it will be power gain. What is power defined as? Product of voltage and current or not. So it is voltage gain, which is beta RL upon RI, current gain, which is beta. So power is beta square RL upon RI. This is formula to be used for solving problems based on amplifier. Right.
Done, sir.
Oscillators. If AC becomes DC, what is the device called? AC DC device called as what? Rectifier, na? AC to DC.
Yes, sir.
And AC to AC of desired value. AC to AC of desired value, either larger or smaller. Transformer, step up, step down. Hello?
Yes, sir.
And
Yes, sir.
amplification of peak signal, amplifier. So oscillator is neither of this. अभी नाम है oscillate, so it will convert DC to AC. So a device which produces high frequency AC signals from DC are called as oscillators. It consists of basically two units. First is called amplifier that we have studied. Second is feedback circuit. It has LC circuit in it. Means inductor capacitor होता है. फीडबैक मतलब आपने ही कुछ किया और आप ही फीडबैक दे रहे हैं. लाइक सपोज वी गो इन रेस्टोरेंट, वी हैव टू गिव फीडबैक. तो वो अपने ही खाने का आउटपुट मांग रहा है ना, कैसा खाया हम लोग, कैसा था टेस्ट. सो व्हेन आई टेक आउटपुट फ्रॉम माय ओन इनपुट, that means when I write on a book and study after 2 years, so I have only written, that was my input, and that only I am reading, that is my output then. So from my output, if I take again input, what is that called? Feedback. Hello? Hello?
Yes, sir.
What is meaning of feedback? Process of taking input from its own output. दो टाइप का फीडबैक होता है, एक पॉजिटिव एक नेगेटिव. सो प्रोसेस ऑफ टेकिंग इनपुट फ्रॉम its own output is called as feedback. There are two type of feedback, positive and negative. So just copy till this, then we'll see what is positive, what is negative, and what are block diagram of feedback circuit without any just plain feedback, then positive feedback, then negative feedback. Completed writing?
Yes, sir.
There are two types of feedback. First, positive feedback. When feedback signal and input signal are in phase. Are in phase मतलब crest के साथ crest मिलना चाहिए. Are in phase with each other or phase difference is 0, then feedback is said to be positive feedback. So your phase difference will be 0, 2 pi, 4 pi, 6 pi, then it is called positive feedback. Now negative feedback. You can also consider positive means constructive, negative means destructive. So when feedback signal and input signal are in opposite phase, then feedback is said to be as negative feedback. Please copy these 2 points, positive feedback and negative feedback. हो गया क्या? हाँ बराबर टाइम लग गया है. ठीक है करो क्योंकि फिर वो अच्छा हो जाएगा आप करके दोगे तो चलेगा चलेगा. और ना उसके बाद एक स्टूडेंट आने वाले हैं 3 बजे तक, मानसी जैन नाम है, आर बैच के. वो फीस देंगे, कलेक्ट कर लेना और नोट्स दे देना वो स्प्लेंडेड वाला. हाँ और उसके बाद आएंगे तो मुझे फोन कर देना. ठीक. हाँ और एक पेपर भेजा है संतोष आर बैच का ही, वो भी चेक कर देना. Yes, completed full.
Yes, sir. Done.
Then I'm just drawing block diagram for only feedback, positive feedback, negative feedback, then obtaining condition for sustained oscillation. So first here feedback or just oscillator. It consists of two units. One is called as amplifier. Second is feedback circuit. Feedback. From here we give input, and then from this output we take input back. From output we take input. So this is called as feedback. So here part of output voltage is obtained as feedback here. First block diagram, I think you followed. Hello? First block diagram followed.
Yes, sir.
Now positive feedback oscillator. It consists of amplifier, feedback circuit, and one device which mixes the signal. It is called as mixer. Now here what we are going to give is superimposed signal. So this is output which comes here from feedback circuit. Part of output is obtained, and this is signal here. This is input. So signal voltage and this feedback voltage, they are in phase with each other, and this way we get output which is applied across amplifier. So when input signal, feedback signal, they are in phase with each other, then this feedback is called positive feedback oscillator. Third one, negative feedback oscillator. Negative feedback oscillator. Mixer, amplifier, feedback. This is output. Here feedback voltage which is part of output. Signal voltage. Together it is V input. So signal is this and feedback is this one. Opposite phase. So my input will be either crest पड़ा रहेगा तो ऐसा, trough पड़ा है तो ऐसा. So this is nothing but mixer, amplifier, feedback circuit. I hope all the three diagrams cleared with you. All the three diagram clear? Ankita, Rahul?
Yes, sir.
Yes, sir.
Okay. Yes, clear? Yes.
Yes, sir.
Yeah. Draw all the three.
Done, sir.
Obtain condition for sustained oscillations in positive feedback oscillator. Let VO, VI be output and input across amplifier without feedback. Without feedback. Thus, voltage gain or amplification without feedback, A equals to output voltage upon input voltage. Let Vs be signal voltage. So V input is signal plus part of output voltage. So signal voltage will be V input minus part of output voltage, which is feedback. So amplification with feedback, AF is output voltage upon signal voltage. So output upon VI minus beta times V naught. Beta is here not current gain, it is multiplier factor. So we'll get V naught. I'm dividing by VI, numerator and denominator. So we get F equal to A upon 1 minus A into beta. So formula for feedback with amplification, amplification with feedback is A upon 1 minus A into beta. Just copy till this, then I'm writing condition when this will happen. Sustained means it is for infinite time. So again, I should get input. That is possible if denominator is 0. Denominator will be 0 when AB is close to 1. That is actually condition for sustained oscillation. You will copy this, then I'm writing in word.
Done, sir.
Can I clear full?
Yes, sir.
Therefore, for sustained oscillations, first AB should tend to 1. That is, AB is nearly equal to 1. This condition is called as Park-Hawson criteria. Second, feedback must be positive. Third, phase difference between input and feedback signal and feedback, or you can say between signal and feedback, must be 0 to pi dot dot dot. Right, these 3 lines. Now tomorrow in one lecture I will complete entire theory of this chapter and then start with MCQ from start. और या तो कल पूरा ट्रांजिस्टर बेस्ड एमसीक्यू कर देता हूं आपके लिए.
Done.
So this much please revise and be ready tomorrow. Not theory, I will do all MCQs related to transistor because transistor part we have completed. And then next class only gate